Greetings, everyone. I'm going to start here with my Facebook page. We're looking at dimension, not the first time, the concept, that is, of dimension. A great little essay picks up here with Margaret Wertheim, if I'm pronouncing that correctly, giving us a good history on medium. I think we're on Aeon, whatever that is, giving us a good history of this concept of dimension, which I've also talked about in Linda Dalrymple-Henderson's book about non-Euclidean geometry, the fourth dimension, and modern art, and so forth. These are key terms in my channel because I talk about Bucky Fuller a lot, and he paved the way for a different namespace, yet another way of talking about dimension. And before he came on the scene, as I've discussed in other videos, there were already some ways to talk about dimension. So I'm going to go through a slideshow here on that concept as it appears in Synergetics, but in contrast to how it's already been used in other contexts. Obviously, you can't ab initio just create a concept like dimension from nothing. It's playing against thousands of years, let's say, of prior use, and that's against that background that you get some kind of traction to maybe say something different or to go in a different direction. So this is a slideshow you are welcome to use. Yes, it's by me, but I don't mind someone else taking it up and giving it a different narrative, talking about it differently. I just thought I'd do a few of these myself. Like, this will be one presentation, but I could do this another way, and others could use this too. Like, feel free to use these slides. You can give me credit, but then take it away, do it your way, or just use it for inspiration and do something completely on your own. If you feel that's not reinventing the wheel, or you think reinventing the wheel is a good thing, which it is sometimes. So Synergetics is a 2-volume printed, published work from the late 1970s. Do I have that right, or was it the 1990s? Gosh, it all blends. But yeah, late 1970s. We've got these Synergetics from Macmillan. And Fuller, he's kind of outside the categories. As his colleague Applewhite put it, he's hard to pinpoint. Is he a philosopher, an architect, or whatever? And the result is he gets passed around, kind of like a hot potato. He's not really from my tribe, so you go explain him. And it's always someone else who needs to read it and understand it. It's kind of an uphill battle reading Synergetics. Why would you do that if it's not assigned reading in the university or something, which it usually isn't up till now. So this cube is where to really focus a lot of attention. And the way I've structured these slides is, first we say, okay, this is kind of our doorway into another world, which we're going to then appreciate. We're going to say this is a world worth coming into. It's worth the little bit of conceptual swagger or bluster. It'll take a little breakthrough to get in here, but then it's worth doing. So come on in, the water's fine kind of attitude. So we've got a cube, nothing controversial here, with edges square root of 2. We say square root of 2, and already here Fuller would question whether we have to do that. Because you can use a triangle, which is simpler than a square, to demonstrate the square root law, or the second root we could call it if we didn't want to say square. And that's the beginning of our chipping away at this cube as like the god of third powering, because what we're going to say is, yes, all these linear dimensions are correct, but we're also going to assert that the volume of this tetrahedron inside the cube is 1. And we're going to assert that the cube therefore has a volume of 3. And that's kind of a contradiction, because right away we see that if the cube has edges second root of 2, then clearly the volume is going to be that edge to the third power, right? I've talked about this before. So let's say you're a teacher and you want to go through why we study synergetics, or some of us do, which I categorize as a kind of like American literature. Let me turn off my ringing cell phone. It comes to us from the New England Transcendentalist tradition, And what it contains, what's different about it, is it contains an alternative interpretation of what it means to raise something to the third power. We don't say cubing out of reflex, which is the habit we all learn in school. It sounds like you know your stuff when you say cubing as a synonym for third powering. That gives you kind of a sophisticated edge, but not in the synergetics world. There you haven't checked your reflexes or whatever. We would like to use 4D in a different way as well to help the tetrahedron come into the foreground as the primary shape. And it's very four. It's got four edges. That's what it doesn't have. It's got 6 edges. So you can have a zigzag of 3 non-coplanar edges. That zigzag of 3 edges, not all on the same plane. So the first 2 edges, if you make a V, that's going to have to be some kind of beginning of a triangle. And you can't help but make a V when you make something with 2 edges, right? And now what do you do with that third edge? You could close off your V and call it a triangle, or you can take either point. Let's not take the common vertex, but let's take either endpoint and stick another little segment off of there that's not coplanar with the first 2. And there you've got our idea of space, and you could say that would be our genesis for the idea of 3D. But then you'll note that there's always a complementary zigzag. Like once you've got those 1, 2, 3, 4 points, you've defined not only 3 segments, but a complementary 3 segments and an inside and an outside. The whole thing just snaps into view as a whole. The tetrahedron is kind of the beginning of volume. Now, I don't know if Kant would agree with that. He might not want to go that far. Can't we just have space without any shapes? Do we have to start with sticks? Can't we start with spheres? Why do we have to start with straight edges? Aren't these just artificial rules? But let's say we do start with straight edges. The tetrahedron is the simplest volume. It has the fewest edges that you need, and it has 4 faces and 4 vertices, and that's where the 4D emerges. And we have another coordinate system as opposed to, or as in contrast to, X, Y, Z if we want. We can deploy something to sort of upset the paradigm, make a little bit of noise, maybe the coupler, unit volume. So this is where we're showing to teachers at first why we want to come here, because we have such a beautiful little Zen garden, you could say, a little ecosystem of interrelated volumes. And you're probably hoping I will discuss these more, but I want to keep this a short video and really focus on the Jupyter Notebooks in the background as where the computations are, and I'll put links to those in the comments. Like the S module here, what we do is we not only define this S module as that shape, of which there's a left and a right, but then we start to phi scale it up and down. In other words, we increase all edges by a factor of phi, which increases volume by a third power of phi, and this is not in the 2 printed volumes of Synergetics. So we're talking about how has it survived or thrived or whatever since its publication. What's happened since then? I have a little pamphlet called The Invention Behind the Inventions. I'll put a link to it, Synergetics in the 1990s. So that's what reminds me that this came out, I think in 79, 80 or something was the actual publication of these 2 books. And then since then, a small click or several clicks have sort of gravitated into this work and done what they can with it, right? It takes time to, first of all, digest, and then how to extend it, in what direction, lots of different pioneers. And David Koski is the guy who's worked most in telling me what he's done. Think of me as the journalist who receives reports from the field about active research in synergetics. I've heard the most from David, and he's into phi scaling the S module and the E module, and then coming up with these identities such as I'm showing on the screen. And depending on how much time you want to devote, if it's a whole course, if it's just one talk, you can get deeply into that, or you can go quickly. We also have another volume formula. There's a history behind this. In other words, there's other thinkers, Euler and before, who've done these complex computations around just having the six edges of a tetrahedron. You're going to second power all those lengths, first of all, and then do all these like manipulations. And it comes out especially elegantly when we just want the so-called tetravolumes of a tetrahedron. In other words, a tetrahedron with edges 1 will have a volume of 1. Now, way back before, and we're going to get to that same picture again, I put this picture on both sides of the slideshow. I'm talking about this picture where we have the initializing cube. You'll remember that was a 2. So why am I talking about a tetrahedron with edges 1? Well, it has to do with these two spheres that are kissing here. These two unit radius spheres define an edge that is 2 in terms of radii, but 1 in terms of diameters. It's 1 diameter. So that's where we get our edge is 1, and so the cube has edges square root of 2 over 2, or second root of 2. Then comes our changing the meaning of third powering. And I have other slides and other talks that can make it more intuitive by doing it in flatland before we do it in space, right? This other way of showing third powering or multiplying of any two numbers and then any three numbers. So again, there's a lot of meat and potatoes here, and you can fill 2 or 3 hours, 5 or 6 days as you wish. Definitely get into the jitterbug tetrahedron, transformation I should say, and sphere packing and all of that. So, and also Arthur Loeb, important, wrote the preface, the prologue, I guess, to Synergetics. Is it the preface or the prologue? I'll have to look. But he is already, when he writes this prologue, a well-established crystallographer and professor at Harvard, MIT. I went and interviewed him once. We had some good, I don't know, maybe an hour together. I hitchhiked up from Princeton just to hang out at the MIT Student Center and talk to him. I was interested in whether he had, how much of the nomenclature he actually wanted us to learn out of synergetics, because to me, a lot of it is about just the words you choose. Do you want to call things A modules and B modules or not? For the most part, people have not seen fit to adopt this vocabulary. It's very remote by design. Fuller has a passage on that, and it takes some getting used to. And what are the practical applications? Now, in math, we're not supposed to care that much, at least at first, about, quote, practical applications. Consistency, elegance, beauty, they're aesthetic things that can sustain in mathematics regardless of applications. And I've kind of taken that approach with synergetics. I'm very interested in the sort of Platonic synergetics and just the polyhedrons and how they relate, what I call the Sesame Street core of synergetics. We've got these three meanings of 4D by the end of the 20th century, according to me. Now, I won't say that everyone agrees with this. Clearly, we have two 4Ds in the shape of Coxeter's kind of extended Euclideanism and the Einstein stuff, but does Fuller really get his own 4D? Here's where we get into the 2D version, or the flatland version of multiplication. Instead of doing a right angle and creating a rectangle, we just use an equilateral triangle, and you can see what multiplication looks like for this tribe, for this ethnic group. It's not what we do, but it's not invalid or inconsistent. So we're off and running with this picture of multiplication, and then we go from there to three numbers like x, y, z, or our zigzag earlier, tetrahedron, zigzag, whatever. They can all come from the same point. In other words, take the three rays out from a regular tetrahedron's corner, any of the corners, and just extend them by A, B, and C lengths, and then call the volume so obtained just by connecting those endpoints, closing the lid. Call that volume A times B times C. It's actually consistent. You can do that. And that's where we get the unit volume tetrahedron. which we then relate back to um, ordinary XYZ arithmetic, geometry, the Greek stuff, the Western European stuff, what we all learn in school. There's a little bit of a nomenclature issue going on here with S3 in synergetics. That's the synergetics constant to the third power technically, but we also like to have it represent the S module volume up, phi up. So when you raise all edges by phi, lengthen them by phi, volume goes up as a third power of phi, and so we do capital S3 to say that's what that module is. And here I'm not saying that. Here my S3 is being the second root of 9/8. That's the synergetics constant. So then I come back and explain, okay, now we've seen we have two ways we can define third powering or multiplication of three numbers in general. And according to one way, we have a cube of second root of 2 to the third power. And according to the other way, this cube has a volume of exactly 3. And we can hold both ideas in our mind and come back with a conversion constant going between the two worlds. So we end up not with a conflict, but with a simple sort of bridge between two different maths, one that's very known to us, the cube-based one, and one that's alien and unfamiliar, but not hard to get into once you've got the mental tricks. So what I've proposed here is that we add to sort of this American literature branch, American transcendentalism, in its sort of utopian in its flavor, positive utopian, not dystopian, not negative. So it's a worthy investment, I would say, and it's off to a good start with some sort of foundational revisioning of how we could use words like dimension, system, event. They all go into this synergetics in kind of a prose way of talking, way of thinking. It's a language. Synergetics is an invented language, you could say, based on English. How about that? Or based on American English if you want. It's enough different and it's enough like a language that there's actually a 4-volume synergetics dictionary by Ed Applewhite, who collaborated with Bucky and was a friend of mine late in his life. We got to know each other when he was in his 80s, I think already, maybe 70s. He didn't live quite as long as Fuller, I don't think. He had a congenital heart issue and decided to opt not to go with surgery. He said a lot of his friends had gone with surgery and didn't seem to have all their marbles after, and he wanted to have all his marbles to the end. That was Ed Applewhite, Edgar. All right, so this is another book that I've been mentioning a couple times as pretty good on explaining the meme 4D up through the 1900s. Then where we go from here, I think, is towards greater clarity about what Fuller was talking about. And then I put these slides in the end to kind of transition to talking about what's established, what's outside, what's inside. In other words, is synergetics still battling to become accepted, or is it already in the culture for the long haul and not really in danger insofar as, you know, it's well established, in which case synergetics is more like a windmill, not like Don Quixote, right? So it's a spectrum, right, between the establishment, which I'm going to say is the windmills, kind of the Dutch, I'll think of it as sort of the Dutch middle class or burghers, and they are in charge of everything. They're like the 1%. And then we have this kind of Robin Hood figure, Don Quixote, and I think Fuller is often cast as kind of a Robin Hood or Don Quixote, but I'm arguing he's more Grunch. He's more like he's a giant and he's not going anywhere. So I might be going somewhere, but he's safely, you know, published and everything. So whether I stay obscure or not isn't important. I feel like Fuller has established a legacy that's not in any real big danger. So it's not super risky for me to put some eggs in that basket. I feel like I'm being pretty like prudent in doing that. So, but I'm not one of the many doing it. I'm one of the few. So I encourage you to take my slideshow like this and run with it. Learn what I know and then adapt it. And there's a picture of Ed, also Jay Baldwin there, another very close collaborator with Fuller, and Ed returned some of my papers kindly rather than just sending them off to Stanford or whatever, so I could censor them or redact or whatever. So he called them quirky, which I agree they were. All right, thanks. I hope that was intelligible to some degree. And again, I'm not doing all the rendering of this content because I know that it's intelligible and other people will pick it up and don't need my, exhaustive treatment. I can just connect a few dots and you guys can take it from there. Talk to you later.